Welcome to Bawashiri Electric once more. So here is a challenge. Could you imagine having a motor starter with only one and only one normally open push button to act as a stop as well as a start to control your motor or any electric load available? Wow, it could be a quite number of wires, it could be quite a number of relays and other components to deal with. But what do I use? I choose a microcontroller, and here we go. It is an easy, cheap and flexible to deal with. I give you a simple preview. So this is a simple preview of how I do it using a microcontroller. As you see, this is one normally open push button. When I say start, my motor runs. You see, when I say stop, my motor stops. I just give it a simple power, 12 volts power from a power bank or any other power source. Then this is the main power that is supplying the motor. Just due to lack of the motor and the contactor, but you can power using anything, and you can power anything, maybe a contactor to cover a heavy load. So how did I manage to come up with this circuit? Please watch the video up to the end and get to know how I did it. All I need to do, I have to open up my software for the microcontroller, and that is Arduino IDE. And in Arduino IDE, once you open it up, we shall have this simple sketch here. And in this sketch, we shall have to write only a few number of codes. First of all, I have to initialize the words. I have to tell the software the words I'm going to use. I'm going to use a word button. It's going to be a number, so I'm going to say int button. You see? Then I'm going to have another word. I'm going to call it int button state. Then I'm going to have another one of Boolean type, and I will call it state. Are you see? Don't forget the semicolons, please. When I come in void setup, here on my board, I'm going to use some pins and I'm going to describe them. I'm going to have pin mode. Here I'm going to use pin. I'm going to use pin 22 as an input. Semicolon. Then I'm going to have another pin, and I'm going to use pin 52 as an output. Then initially I'm going to have my digital write pin 52 high. So 52 should always be high. That is a semicolon. Then I'm also going to say state equals, remember for a boolean we have only two values, that is false or true. So here I've just tried to initialize the pins I'm going to use and the words that I'm going to use in my software. When we come here in void loop, I'm going to say button state equals digital read 22, because my button shall be connected at pin 22, which is an input, semicolon. Then I will say if button state equals low, I see, and state equals false, what should happen? I will have those curly brackets. So if button state is low and state equals false, 1, it should change the state to true. semicolon. 2. We shall digital write. Digital write our out pin, which is 52, to high or uppercase high. Don't forget the semicolon. Then we shall have a bounce delay. Of around 500 milliseconds. Don't forget a semicolon. So that is when button state is low and the state is false. Then we shall have another condition, and that is if else. If else button state equals, here we use double equals. Sorry. If button state equals low, that is when it is pressed, and state equals true, what should happen? Shall have curly brackets here. First of all, state should turn to false. Oh, this IDE is case sensitive. Then after turning to false, then we shall have digital write our output pin, which is 52, low. Don't forget the semicolon. Then it shall also have a bounce delay of around 500 milliseconds. That is our simple code, please. And this is only what we have to load into our microcontroller, and we come up with what we want. So now, before we do the uploading, I've done saving. I've saved my code. Don't forget saving, just here, file, save, like that. But before we upload, let's first go through our code. I said this is int button state, boolean state. Pin mode 22 is going to act as an input. Pin mode 52 is going to act as an output. Digital write 22 high. So we are going to keep our input high. State equals false. Boolean has either false or true. So in the loop function, we said button state equals digital read 22. So it's going to tell us whether 22 is low or high. Then we say if button state equals low, that is when 22 is low and the state is false. It will first change the state to true, then it will digital write 52 high, our output. Then this is bounce delay of 500 milliseconds. Then else if we are making corrections, else if button state equals low and the state equals true, then we have to first change the state to false, then digital write 52 low, then a bounce delay of 500 milliseconds. Let's do the hardwiring. Then we load our code and we see how it goes. Watch up to the end, please. Wiring I have here, this is my normally open push button. As you can see, normally open. I have my Arduino board here. Then I have my connection wires. This is my power bank, my little power. And here I have a relay. Since my Arduino board cannot power a heavy load, I use a relay in the middle. So now we are going to do the wiring. As you have seen in the program, here I've used pin 22 input. That means my push button is going to go in pin 22, which is around here, one side. Then the other side is going to go in the ground pin, which is around there. So I will get my cable and connect the output, which is here, pin 52. So the output signal from pin 52 is going to go to relay. I'm going to use, there are 4 relays, but I'm going to use only one. So I'm going to use relay number 1. That is it. So, but now the relay board, I have to power it to give it a little power of around 5 volts. And my Arduino board can give me 5 volts from here. I'll give here 5 volts supply. Then the ground, I'll give it here, the ground pin of the relay. Then, of course, here I've used one relay, the normally open line of the relay. This is the main power, supplying the motor through the normally open of the relay to the motor, then neutral back. I think that one you can understand. Then I'll have my USB I put in the microcontroller. Now, when I power initially this microcontroller without programming or without feeding the program, like that, when I press the push button, you see, nothing happens. What could I have forgotten? To load in our program. So I'm going to take this circuit into my computer and load in my program. We are there. Recording in a computer just now. So here I'm going to load. After saving my program, I'm going to go. Remember, we have done a small correction in our program. You follow critically, and it is as few lines as that. Then I'll click here, upload. Compiling, uploading, done uploading. So which means we are ready to go. I can run it from the PC, no problem, but let me also show you that it can run without the programming PC. So I'm going to power back my power bank or any other source of power you may have that is from 7 to 12 volts. So when you check my push button now, when I click start, when I click it stops, when I click I push it starts, when I push it stops. So that is how we can use a one normal open push button as both start and stop, which is not the case with our real wiring needs. Thanks for watching. See you when you see me. Please don't forget to subscribe. Bye bye.